Hello, it's Keith here, and this is lesson 22 of the platform-specific series of my 68,000 assembly tutorials. This week we're going to be looking at sound on the Sinclair QL. We're going to learn how to make the QL make its limited beeps. It's not the most advanced sound system, but it's still worth looking at, and that's what we're going to do. Now, first of all, you do have to bear in mind it depends what emulator you're using. If you're using QL2, which is the one I often use, that doesn't support sound. So if you run today's example, you're not going to hear anything. It's not a bug in the code. It's the emulator doesn't support it. So we're going to be using QEmulator today, but there's a bit of a problem with QEmulator at the moment. It seems to be some kind of time-limited beta, and it pops up warnings saying you're expired. So I've had to set the clock back on my computer. What you need to do is there's a registry entry if you're installing it and you've got a copy, delete the registry entry related to it and then reinstall it and it should work again. But hopefully the author's going to either remove the time bomb or release a new version that doesn't have that time limit, because it never implied it was a time limited trial version or anything, but it stopped working. So anyway, that out of the way, we're going to have a look at the code today and we're going to hear the QL play some sound. So let's hear the QL make its noises. Now we can hear the sound going. Now this is Chibi Sound, which is a little sound driver that I wrote originally for Grime. It works in the same way in all of the systems. It plays simple notes based on a 6-bit pitch. There's a 1-bit volume, and I'll come back to that in a second, and there's a noise bit, and you can hear the noise effects right now. The volume bit's a bit of a problem because to my knowledge there's no way of making the QL change the volume of its output, so I'm ignoring that bit, which is a shame, but as I say, don't think there's actually an option. So anyway, there we go. We can hear that the Sinclair QL is making some noise, and you can hear QEmulator is able to emulate the sound, at least when it decides it wants to run. So what are we going to do today? Well, we're going to learn how that Chibi Sound driver is written. You can see Chibi Sound just here. It's very simple. We pass a single byte to it in D0, so we're starting from hexadecimal 80. We're repeatedly decrementing it with this subcommand here, and we're just repeating around, running the program over and over again. The actual job of making the sound is done by this driver here, so Chibi Sound. And you can see here there's the definition, so 6 bits of pitch, 1 bit of volume, which isn't going to do anything in this case, and 1 bit for noise. Now the way that we operate sound in the Sinclair QL is we have to use a trap. So we've got the trap command here, and depending on what we pass to it is going to depend on the kind of sound we're going to make. So what we need to do is we need to load in a definition of a command, which is a series of bytes here. You can see we've got a few examples. We're going to have a look at them. We load the source data into A3. We run trap1, and we need to load hexadecimal 11 into D0, and that's to tell it to send data to the I/O CPU that handles the sound. So this is kind of our fixed instruction to send data. It also does the keyboard, but in this case we're doing the sound. And here's the command which will make the sounds. So we've got 2 kinds of command. One to silence the sound chip, which is command hexadecimal B, and one to play a sound, which is hexadecimal A. And we'll look into the details of what we're actually sending there in just a moment. So when Chibi Sound starts, the first thing we're doing is we're checking all the bits. If all the bits are 0, we're going to silence the sound chip, and we do that by jumping down to here. Now when we want to silence the sound chip, we load in this command here, and this command says we're going to use command B, which is a specific command of the Sinclair QL to silence the sound. The next byte is an instruction saying number of bytes to follow. There are no bytes to follow, so we've got a 0 there. And then we've got the send data. We don't need to send any extra commands here. The silence command is just itself, so that's a 0 as well. And then we specify the return parameters here, and we're specifying a 1 here to tell it there's no return parameters. So that's the entire command to silence the sound chip, a special command. And so all we need to do is we load that into A3. We then jump back up to here to save a little bit of memory. We load hexadecimal 11 into D0, which is command 17, which is send request to the I/O CPU. And then we run trap #1, and that will actually send the sound command, turns off the sound. That's it. Very straightforward. Now, if we're not going to turn off the sound, we're going to be a little bit more complex here. So we've got our complex sound definition here, and what we're going to do is we're going to patch in the pitch and the random noise, if required, into the correct locations within this sound command. So let's go over the sound command and learn how it's actually made up. So the first command is hexadecimal A, that means turn on the sound. Then we've got the number of bytes to follow. Then we've got the byte parameters. Now this is a complex command, but basically each of the bytes that are sent, we need to tell it how many bits we want to use. So we're just going to use this as 4A's here, and that will tell it to send all of the data. Now we've got 2 bytes for the pitch here, so we've got them set to 0, but we're going to patch a new pitch in just here. So we're going to change pitch 1. That's what this offset of 6 is doing here. So we're going to change pitch 1, and we're also going to change the randomness. We'll come to that in a moment. So pitch 2 we don't need. Our definition for Chibi sound just has 6 bits here, so we don't need a second byte at all. We've got an interval between steps. We're not going to use that. We've got a duration. We're just leaving that as the maximum because we turn the sound off when we want the sound to stop. And then we've got steps in the pitch. Again, we don't need that. And then randomness of the step. And this is how we're going to create the noise effect. Now, it's a bit strange, really. I mean, we've got all of these options here for the Sinclair QL, which is great. You know, we can do some changes to the duration and the type of pitch and tone we're making, but we've got no volume. Very strange. Anyway, that's what we got. And again, there's no return parameters. This is really for the keyboard operations, which, as I say, it's the same trap and the same function that we would actually be calling. And we've looked at that in a previous lesson. Okay, so what we're now going to do is we're going to load that into A3, that register here, and then we're going to patch in the settings into the data here in RAM and then send it to the sound chip. So the first thing we're going to do is we're going to set the pitch. So what we're doing here is we're loading the 6 bits in here, just incrementing it here, and then we are patching it into entry 6, which is of course this line just here. So we're altering this command just here by offsetting A3 by 6 here. Now what we want to do is we want to set the noise. Now if the noise is off, we want to set the bits to 0. If the noise is on, then we want to set the bits to CC, and we're going to set the entry just here. So what we're doing is we're loading D0 with CC here, testing bit 7 of the past register, which we've moved into D1 here, and then if the noise is on, we're just jumping over to here. If the noise is off, we're running this section and turning the noise off here. And so what we're doing is then we are loading the correct value into D0, and then at this point we're loading that into entry 13, which is this one here. At this point we've then set all of the settings that we wanted to, so the last thing to do is actually call the trap with D0 as the hexadecimal 11 and A3 as the sound command, which is of course this, which we loaded up here, and that will make the sound that we need. And that's really all there is to it. So because the firmware trap is doing all the work for us, it's very easy to set up sound on the Sinclair QL. Now, I'm not a massive fan of using system traps, but I know no other way of getting the sound working on the QL, so that's what we've had to do today. Anyway, I hope you found this interesting. If you want to play around with Sinclair QL sound, this should give you a bit of advice on how to do it. Thanks for watching today, and goodbye. If you enjoyed today's lesson, please check out my website. We've got tutorials, source code and development tools for 6502, 68000 and Z80 systems, and a lot more systems coming in the future. We're going to be covering the 8086 and the ARM and a few other things as well going forwards. And if you've liked this lesson, if you've got questions, comments or suggestions on how it could be made better, please consider signing up to my forum. It's free of course, and you can come along here and you can make suggestions, you can ask questions. And if you've got assembly projects you're working on, please let us know what they are. Maybe show off a few screenshots, tell us what things you've found interesting or what tricks you've come up with, because we'd love to know about it. Anyway, thanks for watching today, and goodbye.